Bismillah ar-Rahman ar-Rahim. In this video, I'm going to talk about first order differential equation, how to solve using separable variable. Separable variable. If we have differential equation like dy dx equal 8x. In this example, we can with cross product and write y left and x right equal, so 8x dx. And then take the integral for both sides. So I have here y equal to, and this one will be 4x squared, was divided by 2 plus c, and this is the solution. That's the answer. Another example. That is said, you have dy dx, example, dy dx equal to cosine 6x. So also can use a cross product, right? Y right, left equal, and right cosine 6x dx right equal. Take the integral for both sides. I already separated. So we have y equal integral of cosine sine, but we need 6. So you have to multiply by 6 in and out of the integral divide by 6. The derivative of cosine 6x, the angle 6. So now we have cosine 6 cosine 6x dx. So the answer of cosine u du is sine plus c, and before the integral we have 1 over 6. So that means the y equal the solution. The y equal 1 over 6 sine 6x plus c. This is the answer. Okay, another example, write it here. Okay, another example. Let's say, for example, I have here, in this example, y dy minus 8x dx equal to 0. Clear? So you can take here the integral for each one. So the integral of the first one and the integral of the second one. So the first one is y squared over 2. The second one will be 4x squared equal to what? Equal to c. Then you can multiply by 2, this one. So it will be here y squared minus 8x squared plus c equal to c. Equal to c. Okay. Really, this one, if you multiply by 2, will be 2c. I can write c1, for example. So I can write this one, y squared minus x squared equal to c1, where c1 is equal to c. Okay. Also can be simplified more. I stop here. Okay. Another example. Let's say, for example, I have dy dx equal e to the power 4x plus 3y. How to simplify this one? See, students, I have here dy over dy dx equal to, I can write this one e to the power 4x times e to the power 3y. Because multiply, we have add the exponent. And I can separate variable. I can say now this one dy over e 3y equal to e 4x dx. Cross using here, we divide by e 3y. Now the first one, you can write it as e minus 3y dy. And the second one is integral of e 4x dx. So now the integral of the first one, the integral here, the eu du, so the derivative negative 3, so it will be minus 1 over 3 e negative 3y, and equal to this one, the derivative of 4 is 4, so it's 4 divided by 4, so it will be 1 over 4 e 4x plus c. Plus c. Can be simplified. Can be multiplied, for example, this one by negative 3, I can write it as negative 3y equal to, this will be minus 3 over 4 e to the power 4 x minus 3c, and even this one I can write it, this one negative 3 over 4 4x plus c1, where c1 is negative 3c. And also here, I can take the ln and I can divide by negative 3. So I can simplify more and more here. Also, I can simplify, take ln, and then I can divide by negative 3 after this system. Okay, another example. Another example, if we have x multiplied by 2y minus 3 dx plus x squared plus 1 dy. How to separate variable now here? So see, I can divide by 2y minus 3. Then what I have x dx and divide by x squared plus 1. This will equal to 0. See, divide by x squared plus 1. So it will be x over x squared plus 1 plus divide by 2y minus 3. So it will be 1 over 2y minus 3 dy. Okay, so this one. And I can now take the integral of both sides here. So the integral of each one. So this one will be multiplied by 2 divided by 2 will be half ln, half ln x squared plus 1, plus 1. And plus this one also multiplied by 2 divided by 2. So it'll be half ln 2y minus 3 equal to c. Also, this one can be simplified. This one. So uh, I can write this one also as ln c1, and I keep this one in this side. So I can multiply, for example, first by 2, this one. So this one I can write it ln, like here, x squared plus 1 plus ln 2y minus 3 minus 3. Okay, it's 1 ln minus 3 here, absolute value. And this one is equal to, multiply by 2, here will be 2c. Then I carry this one as 1 ln x squared plus 1 multiplied by 2y minus 3 equal to c. This one, I can add the ln c1, for example. Then what I have here, so I have this one, c, this one absolute value here, absolute value high, this one. So I can write this one as absolute value of 2y minus 3 equal to what? Equal to c1 over x squared plus 1. Okay, because this one is ln here I have. And here we have ln of the product. Why? Because I have here the sum. The sum. So I can write it 1 ln. Can write it 1 ln. And another example. If we have, for example, x dy, and I have here dx equal to 10y, for example. So this one, okay, I can write it as dy divided by y. Here I have, so dy y equal, there's cross the product, so be dx and divided by x, I can write over x, then take the integral here. So I have 10. So the integral of this one will be the right side equal to the left side. But the variables are y inside and x in another side. So this will be here ln y, and this one is 10 ln x plus that at the right ln c. Or write c first, at the right c, and then write ln c, for example. Or I can direct ln c from the beginning. So I carry this one plus c. Then, so what about the y? I can write y here. Y I can write it e to the power what, this one? See, I can write this one 10 as a power to this one would be here ln x power 10. Okay, and plus c. So then I can write this one as e. I can write e ln x to the power 10 times e c. So then can be written as this one, c el ln identity. So will be this one is x to the power 10 and e to the power c. I can write it c1, or you can write it k, for example. Okay, so this is the answer. This will be y not equal to k x to n. Well, what about the k? The k is e to power c. Okay, the k to power c. Okay, another example. If I have, for example, cosecant, here I have cosecant, let's say cosecant y dx plus secant squared x dy equal to 0. Also, I can separate the variable c dx, I call this one dx over divided by secant squared x and dy plus dy, I can divide by cosecant y, which is equal to 0. Now see students here, secant squared, this will be here cosine square x dx, and this one will be plus sine y dy equal to 0. What about cosine square? Cosine square equal is the integral of this one equal to plus integral of this one equal to what? Now equal to c. This one is equal to c. Okay, this one now is c. So integral cosine square use the identity, which one? The identity is half 1 plus cosine 2x. Now I have dx, so the integral of the first one plus the integral of the sine y, which is minus cosine y equal to c. Now this one, the integral of this one, the blue one, will be half x, and the integral of cosine. Sine between is multiplied by 2 divided by 2, so it'll be 1 over 4 sine 2x minus cosine y equal to c, this one. Then you can multiply students by 4. We can take c to this side. So I can this one as cf multiplied by 4 will be 2x plus sine 2x, and will be here minus 4 cosine y is equal to 4c, which is you can write it as the k constant. Also, you can this one x to the right side, and you can keep y in the left side.